Can you see this tiny grain of rice? No? Well, imagine thousands of zero-energy devices as small as this in your home or in the office, and now think of all the possibilities of what we could do with that data. Still no idea? Well, that is the exact reason why we're here. So my name is Jasmine, and I want to thank all of my wonderful panelists, these experts that are going to help me talk about this incredible topic. So we have Dave, Eric, Stefan, and Henrik, and they're all going to be here with me to talk about this. So this is our first ever Perspectives Live broadcast. So please talk with us online. Let us know what you're thinking. I can already see that we've got people joining from Nigeria and Israel, India, Brazil, Berlin. So that is super fantastic. We want this to be a discussion and an opportunity to talk. We are here to stretch your imaginations and really talk about this incredible topics with you. So let's begin, and let's start first with just looking at a bit of a basics. I think we need to kind of take it back to ground zero and what we're all talking about. So maybe, Stefan, you could begin with talking a little bit about zero energy devices for us.
Yes, I can try. So my name is Stefan Parkwall. I work at Ericsson Research, nowadays with 60 Research, and zero energy devices is one of the parts we see in the 60 future. And with the zero energy device, we basically mean a device, an IoT sensor typically, that does not need a battery. You never need to charge it, you never need to replace the battery. It just sits there, collects data and reports back. And it gets its energy from the surroundings. It could be a lot of different energy sources. And one example is this small sweater. It's a little bit too small for me. I haven't washed it. It is this small from the beginning. It's a sweater done at MIT, the university in the US. And it actually contains about 1,000 sensors in the fabric, pressure-sensitive sensors. So by wearing this, you can detect pressure and then predict the body posture and things like that. And to connect that to the surroundings, there is a zero-energy device here. So it's a tiny, tiny chip here and a small antenna that harvests energy from the radio waves, uses that energy to transmit back the sensor data. You can do a lot of things with that. So we have a small video we can look at.
Fantastic. And I also just want to say, if you want to look at anything, just to look at the ericsson.com/perspectives.
We saw there on the video a standard knitting machine that makes the fabric. And while making the fabric, they put in metal threads. Whenever two threads cross each other, you get a pressure sensor. And by using those sensors, each of them may not be that accurate, but many of them, you feed that into an AI model and you can predict whether this man is walking or standing or walking upstairs or downstairs and things like that. And imagine if you put this in the West, a sweater like this, you can see if I'm sitting up, if I have fallen on the floor, could be for elderly care, could be gaming industry, you can go out in the woods, hunt monsters with my friends, for example, or practice the golf swing and see how I move my body and things like that. So there's an endless number of things you can use these type of very simple sensors for. So that's one example of a large number of sensors connected with a zero energy device.
Super interesting. And I think, so here we have one practical one, and maybe Dave, you could share a few more with us. That'd be really interesting.
Sure, thanks, Jasmine. Hi, everybody. My name is Dave Wensloth, and I'm the co-founder and co-CTO at Everactive. We're a company based in the US, and we make industrial monitors like the one I'm holding up here, which is a machine vibration monitor. It can monitor acceleration or vibration on a motor, magnetic field, temperature, vibration, humidity, just several things around the motor to be able to tell the state of that asset. And the best part about it is there's no battery in it. It runs exclusively from harvested energy. We can power from just a few degrees C. 5 degrees C is sufficient to power the sensor continuously. So we can power from the heat of the motor or light in the room, and then stream that data continuously to the cloud. I've got another sensor here too, which is we call this our environmental monitor. So you can see there's a solar cell on the top of this one. It powers by light, and it can measure. There's a picture of it here as well. It can measure temperature and humidity, but it also has an accelerometer in it, so it can tell if it's been moved. And if it's been moved, it can relay that information immediately to the cloud. So you can use it as somewhat of a security type sensor too. So here would be an example of it installed on a door where you'll be able to tell if that door is opened. And again, no battery inside and powers exclusively from light. This one can operate from under 100 lux, which is actually pretty dim indoor light. Like think, putting your hand underneath your desk, the amount of light you would get down there is enough to keep this sensor alive continuously and streaming data to the cloud. And then, another challenge is once you have all this data in the cloud, what do you do with it? So one of the things that we do at Everactive is we develop models and algorithms to be able to predict, let's say, the health of an asset that we're monitoring in these industrial environments, and then provide that insight back to our customers. And we've deployed these industrial monitors today in over 80 sites across the US, where they're up and continuously operating from harvested energy and providing this actionable information back to those customers.
Wow. And yeah, really cool that they have different aspects so you can move them, and if they are moved, you can see that. So that's really cool. Eric, I know that you also work with different types of sensors. We'd love to hear more about that.
That's true. Hi, everyone. My name is Eric Kling, and I'm one of the co-founders of Revive Energy. And we're definitely in the same space as Dave and Everactive, but we use, for our energy harvesting, we use only vibration, nothing else. Some of the devices that we market, you can see here on this picture, and this is essentially a vibration sensor that is powered by an everlasting battery. As long as you place it on a vibration source, these devices will continuously monitor vibration and acceleration, and it will send it to the cloud without no battery replacements ever needed. We're a spin out from Saab, who originally patented this technology 10 years ago, and we exclusively focus on industrial, heavy industry applications. So a little bit different from what Stefan just explained. Yeah, this picture is a pretty good example of where our technology is a really good fit. What you see there is something called a vibrating screen. It's a machinery that is used in a vast range of different industries and applications. It's used to separate material into different grain sizes, and there is a lot of information that you want to get out of this machine, and also the process, the industrial process of optimization of flows, etc. And by using those vibrations from the machine, we can make our sensors completely self-powered and power autonomous, and we can give our customers this large amount of high quality data that they need for this.
Great. And I think maybe we should take a step out of looking at companies that are making the devices and look more at companies that use these devices and also the data. So Henrik, maybe you could talk more about that.
Well, I'm Henrik Eriksson, and I work with workplace strategies at Vasakronan, and we have mainly office buildings in the 4 big cities of Sweden. And it's super interesting. We started connecting our buildings like 6 years ago, and connectivity for us is the road to great experiences. So being here and feeling, the development in all these sensors is super interesting. I will tell you a bit more later on what we're already doing and what we can do about this. But workplace strategy that I work with is basically to try to orchestrate people, culture, and technology and place in order to create a great work life for all the employees. For example, Ericsson, which is our largest tenant.
Yes.
I'm looking forward to talk about how this can create beautiful workplace experiences.
Definitely.
Sounds interesting.
I'm going to give it to you.
And then I'm thinking from that, we could then actually have a look at Tommy. So that is someone who's working in Ericsson. And we asked, from these different experiences, what would be helpful with this more data?
I think it's combining different data sources and using those different kind of data, and then actually creating new services that are not really, I didn't think about it when I started to do it. So it's really using different kind of data sources, connecting it, and then creating new kind of services. And I think that's what will be the big value when you are able to do that in the future.
And obviously the experiences are such an important part of that. And I know, Henrik, you're very interested in them, what we can do with those types of experiences.
It's super interesting because my life since I left the Royal Institute of Technology was mainly defensive strategies. You had to cut costs in buildings. We started creating this ontology, this language of properties, so we could easily get access to that rise. So we could just throw it into a building and it starts to talk to the building straight away. So we started a thing called Real Estate Core, and on that we put a operative system. So what we basically done, which is a huge thing, we have done our buildings to iPhones.
Super cool.
So what I'm waiting for now, I think, is the big next human, leap. I think is when we get human machines working together, and this is possible because it's scalable. And I think Stefan knows a lot more about this. But this connectivity thing is super interesting. In a normal building that we're building at our work downtown, 70,000 sensors.
Wow.
And thanks to the standard that we arranged with Real Estate Core and PropTech OS, we can connect them by a flick of a switch, real-time data. And real-time data gives you predictability, which gives, can give great tenant experiences. And as you guys probably know, we lost the gravity of workplace since COVID. So we're moving into the experience economy.
Yeah.
We have to show people it's worthwhile commuting, worthwhile going, give them great experiences. So that's why I'm here. I'm really curious to see all these rise and all the things here. So
absolutely.
Super cool to be here. Thanks.
Definitely. And also for our audiences to learn a bit about what it can change for them and like what it could mean for them going to work or what it could change for them working from home, let's say. But I think maybe let's jump a little bit back and actually talk. We've been talking a lot about energy harvesting. So I think it'd be really good to just understand that. So maybe, Stefan, you could just take us into a bit of that.
Yes. So as you see on the screen here, it's an examples of different energy sources. We have to the high-end solar power. I mean, if you're outdoor, put out a solar panel, you can get a lot of energy. I think we all know that. There could be other sources as well. We heard from Revive, those vibration harvesters. If you have a machine that is shaking, pick up that energy and use it. It could be temperature differences. I sometimes say that a cup of coffee is energy. Not just for you that drinks it, but also because it's hot inside and it's cold outside. And that difference in temperature can also give you energy. It could be other sources of energy you can think of as well. We talked about vibration, radio waves. They are around us all the time. They also contain energy. Tiny, tiny amounts of energy. So I think the numbers you see on the screen here, they might be a little bit on the optimistic side. So the amount of energy we have available is extremely low in many cases. So that's why we need to design these zero energy devices very, very carefully. There is actually an article on Ericsson.com that talks more about energy harvesting. So if you want to learn more and see more about the details here, you can take a look at that article.
I mean, just to show where we're at. I mean, we already have a building in Uppsala which has what you told me gradation is. The difference between the temperature in the air actually drives this actuator, this thing. So we already have it in the buildings, but I mean, the possibilities are great.
The temperature gradients, yes.
Yeah, the temperature gradients makes this thing move.
Yeah,
really
absolutely.
Cool.
And you can think about if you have some sensors in your shoes and walking around, yes, then you pick up that energy. So it all depends on the application, what energy source you use.
Yeah. And maybe, Dave, it would be interesting to know what that means for you, the different energy harvestings for your products.
Yeah. So our approach has been to look at things more on the energy consumption side. So as Stefan just showed, that the amount of power available goes down and down, lower and lower, as you get to more and more energy sources. And so if you could produce a device that consumes less power, then you can operate it from more of these types of harvested energy sources. And that has been our approach. We do our own custom chip development at Everactive, where we've essentially built a microcontroller with radio, sensor interfaces, power management, everything in a single chip that's about 1,000 times lower power than what you could buy off the shelf. And because it's so low power, we can operate it from just a couple microwatts all the way on the right end of Stefan's graph here. That's how much power it takes to keep our sensors alive. And just to make a comment on energy harvesting in general, I think many of us have heard of projections of 1 trillion devices eventually being connected, 1 trillion IoT devices deployed in the world. Kind of the question is more, when is that going to happen? Not if it's going to happen, but when it's going to happen. But just some simple math would tell us that if there are 1 trillion devices out there today, and they all operated from a battery, and the battery lifetime was 3 years, which is a long time for a device to be able to operate from a battery, even under those conditions, collectively across the planet, we would be changing 1 billion batteries per day. 1 billion batteries a day is how much we would be changing or replacing, which is essentially a battery a week for every person on this planet. And nobody wants that in the future. And so I think the solution here, obviously, is to get rid of the battery and run from harvested energy. And that has been the sole focus of what we've been doing at Everactive.
Very
interesting.
interesting.
I may jump in there. I mean, this tiny thing radio sweater, that was an energy harvester as well. This picks up the radio waves, because that's the most difficult things. We're talking about fractions or microwatts. It's extremely small amounts of energy, but it is actually possible to do. And then you can use that for communication. So.
And that's super relevant for us, because I mean, we already have Wi-Fi sensors and so on, but the thing is the provisioning and the commissioning, I mean, getting in there and maintaining them, we can, the scalability that we can get from this and harvesting real-time data to give predictability at low costs. I mean, normally in hindsight, we always done things at one-off thing. Now we can do it straight away, and we can basically throw in a handful of rice, what do we call rice corn, and just get it sensing and gather all the data. So it's really, the provisioning and commissioning side is very important for us landlords.
Definitely. And I think what we're going to do now is we're going to jump into video. Dave, that's your video. And then we're also going to have some questions. So let's just jump into that, and then we'll go back to Dave.
Everactive's Steam Trap Monitor attacks the largest source of steam waste, leaking steam traps. Up-to-the-minute measurements feed an advanced cloud analytics platform, detecting the failure months sooner than a typical audit. Everactive's Machine Health Monitor gives real-time insight into the running condition of electric motors, along with the pumps, fans, conveyors, and gearboxes they drive. A triaxial accelerometer detects machines running out of tolerance, alerting vibration analysts for further investigation. A thermoelectric generator can power the unit off of temperature alone, and a solar cell can be added to harvest indoor or outdoor light.
And I cut you off there, Dave. So what was it that you wanted to say? And then we're going to jump to Eric.
Oh, no problem. This was a great lead-in with that video. So some of the assets that you saw there monitoring were monitored by our sensors were a steam trap and a motor. And the thing I was going to key in on is Henrik made a comment about deploying 70,000 devices in a single facility. And if you just imagine the logistics of doing that for a moment, deploying those devices, getting them wirelessly connected, that is a significant undertaking, not to mention possibly having to go back to those devices and replace a battery in a year or two. So that logistical undertaking is really prohibitive for a lot of industrial installations. Some of the customers that we're working with in a single facility, they'll have anywhere from hundreds of these assets to 10,000 of these single assets deployed across their facility in environments like the ones you just saw. They're not necessarily the nicest environments to work in. They're pretty harsh environments. And, sometimes it's impossible or very difficult to go back and return to those assets to do maintenance on them. So maintenance-free devices, zero energy devices, battery-free devices, that's very important for really getting these customers to even think about adopting these types of solutions.
And I must say, I mean, you're definitely addressing the very, very major point here. I mean, we are trying to, in our mission as owned by 4 pension funds, we want to create sustainable cities. A sustainable city is optimized buildings that we use to buildings more than 10%, which we do now, and cars which we use more than 5%. Which means that if we have these buildings connected, I mean, smart buildings are connected buildings. So in order to build a sustainable city, we need to have a connected city and smart buildings. So I would say this is crucial for the whole journey for a sustainable city.
Absolutely. And maybe, Eric, do you have any thoughts on this?
I mean, well, I agree. What Dave explains, our use case is very similar to that. with the difference that we only use vibration and not any other sources. So we definitely operate on the higher end of the scale that Stefan showed earlier. And energy harvesting is definitely the core of what we do, is what makes us different from the competitors. But since we are working with only one type of energy harvesting, we really need to pinpoint those applications where our specific technology is the best fit. Yeah, this images here shows one of them. This railway is sort of one of the schoolbook examples where vibration energy harvesting is a good technology to use. And I think you can imagine that if you want to monitor something, a moving vehicle without any access to power, and the maintenance interval could be 8 years, then you really need to look for other alternatives than batteries. It simply doesn't work. So for us, the energy harvesting is definitely what makes us stick out. It's core.
Very interesting. And I think what I would really like to hear a little bit more about, Henrik, you just talked about buildings and how buildings could be adapted to how we're working and how we're living in day-to-day life. Maybe we could also talk a bit about the TSX building.
Yeah, the TSX building is very interesting. I mean, what we have to find a new reason to be for places, for buildings. Because commuting to the office because you must do it is gone. So we are moving into the experience economy that people need to feel being in the building is time well spent. What we see at TSX building here is the beautiful entertainment building in the middle of New York, which revolves around entertainment.
Yes.
Which talks to the consumer, because my work has shifted. Instead of talking to the CEO of a company, I talk to all his employees, and I need to convince the CEO to rent our buildings, that I can convince the consumers to come to the building. But the TSX is a very great metaphor. It's happening now. It's actually up and running. The big picture you see on the building is up already. I think the restaurants will open. Everything will up and running in 2026. It's done by Nick, who is a former Spotify, who was in the entertainment industry, and is connected. As you see, you already start consuming what's in the building while you're home. So you can actually use your iPhone, start consuming the experience in the building. You go there, you can take pictures and get NFTs and everything. So, and when you enter the building, he hasn't got variables at the moment, but you can imagine when you can customize your visit to that building, what kind of gravity that would make. I mean, what that would make you to want to go there often. Because my objective basically with buildings, of course, is to make people consume them. So TSX building is a very interesting thing, and you can just imagine the amount of sensors in that building. We're not talking 70,000. I think we could add 1 0 or 2 zeros on that one.
Yeah.
It's going to be...
Is that my future office?
That, depending on what you're interested in, because we are in a consumer industry.
Okay.
So I will tell you a bit later about, I mean, we have to find the thing that triggers the human being, and we have to customize this experience. And I think the next coming years, the human building interaction scene will be exploding, and we have a very big place for all these sensors there. Because as you mentioned, it's not sustainable to have batteries running around. You can't cost efficient. So what we're standing, I think if we look at this scene 10 years down the line, it's a lot of things going to happen.
Absolutely. And I think let's jump into some questions from the audiences, because we want to show them we are listening, and I see your questions coming through. Eric, I'm going to throw this one to you. What are some challenges that need to be addressed in order for zero energy devices to become more widely adopted? This is from R. Jasmine on LinkedIn.
Wow, that's a good question. And I think that different persons here can have different views on that. But I think one big challenge right now is that for zero energy devices, we cannot really rely on one specific technology. It needs to be a combination of different technologies. There's no such thing as a one-size-fits-all solution. I mentioned the everlasting battery before, that our devices are powered by everlasting battery. And that's true when a certain number of checkboxes are checked. And that means that, there's no universal solution that will cover all Internet of Things cases. There are many challenges with IoT in general, but if we're talking about self-powered IoT and energy harvesting, I think the lack of a one-size-fits-all solution right now is slowing us down a little bit.
Great. Dave, do you have any reflections on that?
I agree with Eric 100%. I think there is no one size fits all. There's no one source of energy that's going to solve or, could be used for all applications for the IoT. So absolutely agree with that. I would add, in the success that we've had in finding customers that want to adopt this is in identifying pain points that those customers have that can result in typically hard ROI, return on investment for them, meaning saves them real dollars. I like to say it's a painkiller, not a vitamin. So finding those applications where the IoT can be applied, but then where it has not been applied because of the battery limitations. And typically that is because of the maintenance problem. Really, we've heard now a number of customers say, I don't want to replace one maintenance problem with another. Meaning I have a current asset that I need to maintain. I don't want to put a device on there and then have to go back there and replace its battery every so often. So finding those applications, I'd say the main applications to go after where we can apply this technology, and then adapting zero energy devices to suit those needs, removing the maintenance issue altogether, I think has been a very successful combination for us.
Absolutely. And we've obviously seen Stefan, who's talking about the jumper, and then we've seen Dave and Eric talking about different devices. I think now we can actually look at a video from Theodore, who's actually going to talk about a little bit more into this.
Yeah, and I can just before you start that one, it's very interesting because I don't see any obstacles. Because, I mean, Stefan, you have to help me out on this one. But what we have done, we have created a standard. So we gather data from the IoT, from the building information management systems, and from the digital twins. So, I mean, the one size fits all, as long as all the suppliers align with the ontology, the standard, Stefan, it's just easy to thrash them in, Is that correct? So
that was exactly the same thing I was thinking about myself. I mean, standard in the same way that the standards has meant that any iPhone, Android, whatever smartphone you have can connect to an Ericsson base station. We need something similar for these devices. We can't have multiple different versions of them that are mutually incompatible. And because when you get the standard in place, then you get the mass market going, price go down, and people start to invent a lot of new things.
And that's, I think, is very important, why people should look into the real estate core standard. And that's Stefan's territory, to standards. But this has actually made this possible. So I would say, yes, as long as people align with that language, it is one size fits all. We can't put them in there and really easily scale it up. Isn't that correct, Stefan?
Yeah, I think so.
Bring in Theodore.
Yes, absolutely. Thank you.
We are living through a health revolution where the locus of control has shifted. Health systems, healthcare providers, and the new patient consumer are all seeking to empower each and every one of us to take charge. This requires a whole new set of tools, new data models, new algorithms, applications, and sensors. As the product officer of Sention, a medtech startup, we are constantly seeking to innovate new devices, new data layers. We want to mix subjective and objective data to find the new quantified self. Zero energy devices has the potential to revolutionize how we move from the wrist or the finger into the mind and the organs. The goal, of course, is longevity and optimized health, proving outcomes and value to each and every one of us. It's a bright future.
Wow, and that is really a great video. It really makes you feel and understand, okay, this has possibilities. And I would say one question that keeps coming up online that I'm going to start bringing into is about sustainability. So I can see Peter on LinkedIn, and also we've got James on Twitter asking about zero energy devices, how they can play a role towards a sustainable future, and if we can give some examples on that. So maybe we can start with you, Henrik.
I mean, it's super easy. For us, we have, as I said, 10% the buildings that we own are utilized 10%. If we can increase that by 10% by using AI to feel how many people are coming into the building, we actually connect the building today with the weather, we connect with the commuting trains, we connect with predictability, so we understand how many people are going to come into the building. We can actually tell Jasmine that if there are only two people, but they booked a room for 20, it will automatically switch. And as Real Estate Core and PropTech OS is connected to Microsoft Outlook and Microsoft Places, we will increase utilization, I would say, like logarithmic in the coming years. So that's a very easy example. Increasing utilization, I think, is the best example, especially after COVID. Because COVID, buildings are not being used. And I think we could really utilize them more, water consumption, electricity, and all that.
Absolutely.
Is that an answer?
Yeah, well, that's definitely one side of the sustainability point of what we're doing with the data that we're getting and how we can be more sustainable with that. But I'm going to throw it back to a different section. So, Dave, that's what you maybe touched upon earlier about the batteries and how many batteries there are, and more of the sustainability from the actual devices. Have you got any thoughts, any comments on that part?
Absolutely. I got a ton of thoughts on that. So yeah, let's go back to those numbers I mentioned. It's 1 trillion devices and we're changing 1 billion batteries a day. I honestly, my personal belief, if we enable a world like that with 1 trillion batteries out there, I think we as technologists, we've failed. So that is an environmental tragedy, first of all. Just, most of those batteries are built on rare earth metals. Those are dug out of the ground. Very few of those batteries, sadly, are recycled. So just they're not a great technology to include in electronics in the first place. And we have this abundance of harvested energy or harvestable energy just that's bombarding us every day. So why not take advantage of that to power these devices? So I think that's certainly one side of it. And then maybe just to double down on the point that Henrik was making, a lot of our customers have their own ESG goals, sustainability goals that they need to meet. And by deploying these devices in those environments to help those companies monitor them, keep them more efficient, reduce their own energy consumption, we are therefore reducing the amount of emissions that those facilities are generating. And I forget the exact number. It's together, all of our sensors that we've deployed at EverActive have already reduced the amount of CO2 that's been generated by, I think it's a couple million metric tons to date.
Wow, that's amazing. Or that's crazy. It's not amazing, it's crazy. Eric and yourself, any reflections on this?
No, I can only agree. I think that what Stefan, also Henrik describes, that's a huge potential to increase the amount of data available to make better decisions. That's where we can really save energy or whatever. But let's not forget the battery issue that Dave's described. If this are going to scale and will, then that will become a very apparent problem. So I agree with both.
Absolutely.
I really think we need to address the video, Theodore, because what it's talking about is a subject that is really important these days, longevity. People really matter about living long lives, being healthy and so on. If TSX was addressing the entertainment side of people, I think the future of work life, what we need to deliver to all the people working in our buildings is an ability to be more healthy, to be more productive. And what Theos is addressing, I think, at that video is that if we connect the people at home that have this jumper here on themselves, straight connected to the smart building, to the temperature, to the CO2, to the sound, to the people around them, and how you commute, your heartbeat, your insulin, and you go to the office and you will get a customized experience with your tailor-made food for who you are, with your sound, so what we can do by connecting the knowledge graph, if you say, with the human being, which Tira is talking about, connecting that with the building, I think we can create huge experiences that are immersive and will drive people to the office,
Absolutely. And I think now taking this into maybe a future look, and obviously talking about 5G and then connectivity there, and then maybe also the 6G, which I know that Stefan knows a lot about. One of the questions we've had online is that we haven't talked about cellular connectivity right now. So could maybe you expand on how that can look?
Yes, I mean, these zero energy devices, we see them as part of the overall 6G vision. So that will clearly be cellular connectivity to those devices, because we have cellular everywhere. So of course we should connect the sensor with that as well. So it is part of the 6G story, but it's actually happening parts of it already now in 5G. So there are standardization activities in 3GPP, which is the organization handling the cellular standards, that are starting to look into these type of devices. So they are coming. And I mean, some of them, depending on your energy source, if you have a lot of solar power, you put up a solar panel and buy an off-the-shelf modem today and get going. So you can do things already today. But things will be even more impressive in the future when we can scale down the technology to run on these tiny, tiny amounts of energies that we can harvest. And in the long run, why not think about printable electronics? Maybe we can print this on paper. Maybe we can even make it biodegradable at some point. So when at some point it ceases to exist and has done its job, it just vanishes. That's also environmentally friendly.
That would be
There's a lot of
incredible.
things you can think about if you stretch your imagination a bit.
Definitely. And maybe on that stretching of the imagination, I have a question online that I think, Henrik, I'm going to ask to you, is asking, could we see zero energy devices to be used to create more resilient and self-sufficient communities, able to weather powered outages, natural disasters, and other disruptions?
Wow.
Yeah.
Well, that's a big question.
That is a big question.
Do it again, please.
Could we see zero energy devices to be used to create more resilient and self-sufficient communities, able to weather power outages, oh my goodness, and natural disasters and other disruptions?
Definitely.
Yeah.
I mean, I am, as you probably hear, I'm more on the positive experience side. What you're describing there is a another side, but I mean, showing the piece of rice that you have, and you can, as long as you follow this beautiful standard that these beautiful technicians have, created, we can do anything really cost efficient and scalable. So I assume the answer is definitely yes.
Yeah, absolutely.
But I'm not that tech savvy, so I shouldn't go too deep down.
No, but I think that's great. And also one question, and I might maybe leave this to who wants to answer this question. Could zero energy devices lead to a future where energy is no longer a commodity that can be bought and sold, but instead a universally accessible resource like air or water? Who wants to? Hands up.
I mean, something to this. We have sunlight all over the world, and that's energy. So there is at least some form of energy available almost everywhere.
Definitely. And Dave, I see you just kind of raised your hand a little bit, and then Eric.
I did. Although I don't know, maybe I should take it back. We've been talking about zero energy devices, but we've not really been talking about, zero energy cars or zero energy, industrial factories or things like that. And I just want to make that distinction that, there are different sides of this spectrum. There's different parts of this equation, and I do believe that we can get to a net, let's say, zero carbon world, right, where everything can be powered from harvested energy. But that's going to take not just zero energy devices to help improve efficiencies of the consumers of that energy, like the buildings that Hendrik is talking about, or industrial facilities, or the locomotives that Eric's been talking about. Those things all consume a lot of energy. The things that we've been talking about today are improving the efficiency of those devices. Meaning they're going to need less energy to operate, which definitely helps on the production side of that energy. It means we've got to produce less energy. That means we don't need as many wind farms. We don't need as many solar farms, for example, to do the same amount of work.
Eric, I think you also put up your hand, and then we're going to come to you.
Yeah, I mean, they've summed it up really good. When we're talking about energy harvesting, we talk about local generation of energy to power a low-powered device like a sensor or something. I would love that vision that you in this question to happen, but in the short term at least, I think we should keep it apart a little bit and understand that we're talking about very small amounts of power, and to that's worries for now. But who knows? Maybe they intertwine at some point.
Definitely. Henrik?
I wouldn't like to spoil the party, but I think that the solution of this question might be in the battery side. I'm not a technician in that way. I mean, as long as my brother is in the electricity industry, and he says, Henrik, there is no lack of energy if we have batteries to store it. But I'm not tech savvy guy, but that's my fast answer. Spoiling the party.
There's all kinds of, I'll just add, there's all kinds of alternative energy storage. Batteries are certainly the easiest because they're electrical and they're easy for us to interface to. But I was in the basement of a fab, a semiconductor fab, which has local energy storage so that if the power goes out, they can continue to process wafers. They can continue to make chips. And their local energy storage was done on flywheels, massive flywheels, the size of the room that I'm sitting in, huge wheel turning, which it holds energy. And if the power goes out, that wheel keeps turning and they harvest energy from the rotational energy that's been stored in that giant flywheel. It's the flywheel is the same thing that's on the back of the engine in your car. It's just a much bigger version of it. Other examples I've heard are storing energy in water. You put water up into a high tank and store it there. And then when the power goes out, you can pull the water down, much like a waterfall or a flowing river. You can harvest energy from that. So there's all kinds of other, alternative energy storage technologies out there. I'll call them technologies that are not batteries. Just batteries are certainly very easy to interface to. So it's easy to go there as a first resort.
Absolutely. And let's now look a little bit at what 2030 might look like. So Stefan, maybe you can give a thought of what you think.
Yeah, in 2030 we will start to see the first 60 systems up and running. And if you count backwards, that means that we need to do research now to understand the requirements from these type of devices. What do you need to do in order to support them in the best possible way? Because in like 2 years or so, discussions on requirements will start in 3DPP, the organization developing these technical standards. And then from the requirements, agreeing what we want to achieve, then we start to do the technical specification and then we do products. So it's really time to think about this now to get a good solution in place in 2030. But I do think that zero-energy devices will play an important role. I mean, we heard a lot about that here today, that we can't have billions of batteries that we need to replace every now and then. It's not sustainable. It's not doable.
No, absolutely.
So these type of devices, we need to do them zero-energy device.
Yeah, and now we only have a very few short minutes left. So let's do a quick, Eric, 2030, what do you think?
Okay, quick then. This has a really bright future. I think that the trillion sensor IoT vision is a few years away, but we've definitely got the ball rolling. And as of energy harvesting, I think that will really accelerate, at least industrial IoT that I am working with. And this development will be fairly fast. And I think that by 2030, I think that energy harvesting will be the primary way to power wireless sensors for the Internet of Things.
And you, Dave?
I'm going to go back to the standardization. I love that as the way that's going to enable the IoT of the future, and meaning we need standards, global cellular standards. We need global cellular standards that are amenable to these ultra low power devices, meaning devices that consume very small amounts of power, because you saw in Stefan's graph how low that power goes from, the source of power goes for these different energy harvesting sources. So being able to wirelessly connect on such small amounts of power is very important. The cellular signaling today is not quite there yet, but there is a lot of activity going on right now. Definitely. To create these new standards. Absolutely. That will get us to that future.
Yeah, and I'm going to quickly, so please, if you want to learn more, head to ericsson.com/perspectives. Thank you all for joining. And Henrik, any final words to close us off?
I must join the standard thing. If we align all these standards, which we've done, real estate core, haystack, brick schema, we will create great experience for the user of the buildings, and that will worthwhile going to, worthwhile commuting to, worthwhile working in. That the road to that is zero energy devices. Thank you.
Amazing. So thank you all for joining us online, and thank you all for joining us here. This has been a fantastic opportunity for us to actually talk and intertwine with each other and really learn a bit more about this really interesting topic. So I really hope for you or the audience and you at home that you've got a bit of interest in it, that you want to learn a bit more. Again, head to ericsson.com/perspectives to be able to learn a bit more and read. And yeah, get chatting. Let's see what we can do. We're the future. Let's see what the differences can happen. So I want to say thank you, everyone, very much. It's been a fantastic opportunity. And that's Henrik throwing his cards away and ending it there.